Good evening, sir. I'm Karthik Patnam from CSAR. Today, I would like to present data flow analysis of flow graph in automated and compiler design. So, data flow analysis collects information about variables as control flows through the program, and it is performed on CFG, control flow graph. So, the purpose is to detect the redundant computations, identify dead code, and enable optimizations. So, to understand the data flow, we use four key terms: in, out, gen, and kill. Information that is entering a block is said to be in, and the information available at the exit of the block is out. Information generated in block B is gen. Information invalidated in block B is kill. So the data flow equations are: out is equals to gen union in minus kill of a block, certain block. So the in is equals to union of out. So here we have two basic blocks forming loops. Both blocks modify prod and I. So they appear in both gen and kill sets. Initially, B1 starts with no incoming data, but its output feeds into B2. Since B2 depends on itself due to loop, values keep propagating until they stabilize. This shows how variable persists across iterations, critical for detecting useless updates and optimizing decisions. Code generation. Code generation is where everything becomes real. This is the final compiler phase. It takes intermediate representation and converts into actual mission instructions. But it's not straightforward. The compiler must choose efficient instructions, manage limited registers, decide evaluation order, and handle memory correctly. Good decisions have impact on performance no matter how good earlier phases were. So here's an example. This example shows how high-level operations translate into machine instructions. First, T1 is equals to A plus B is stored in a temporary variable. T1 is a temporary variable and then multiplied with C. That is again stored in another temporary variable. So the compiler maps these two registers operations: load, add, multiply, and store. Everything happens through registers. That's because direct memory operations are always slower. Efficient register usage is what separates optimized code from slow code. So this is my topic. Thank you, sir.